Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 7.2, Polar Area. So, as the name suggests, polar area involves using polar coordinates to find an enclosed area. It is fairly straightforward to do so, except sometimes you would need to think a little bit beforehand, because your limits would be in terms of radians, and so sometimes you would have to split your curve into two separate parts to carry out your calculations, but at other times you'd be able to just simply carry out a single integration and you would be able to find the area. So let's have a look at how to do that in the examples. So let's have a look at this particular curve. R equals to 4 cosine of theta. So if you know the sketch of this, this is a very standard sketch, and you would be able to find a circle. It is a circle, it's just me being bad at drawing. And it would have the maximum of 4 on the x, and it is a circle center 2. So in order to plot this curve, technically I should have drawn this in dotted lines, so I'm gonna actually do that. So let's so let's put that in dotted. Now with that, we can tell that we have gone through 4 pi on 2, then go to negative, we have the other pi on 2, so we have an entirety of 1 pi. So in order to find the enclosed area, would have to have the limit of pi from 0 half r squared d theta. So this half r squared d theta is just a standard integral, so you will have to remember this formula whenever you do a polar integration. This equation comes into play, and the only thing that changes is the r and the limits. So do remember this equation, it's helpful. So let's have a look at this enclosed area, shall we? So in order to carry out this integration, first of all we need to break this r into the equation, which gives us 4 times 4 is 16, divided by 2 is 8, lots of cosine squared theta d theta, which is all fine. Right, my pen just ran out of power, which is a pretty big problem. Cool. I guess I'll have to use my mouse for the rest of this video, which will be a problem. Okay, so we have 8 cosine squared theta d theta, which is all fine. And in order to integrate 8 cosine squared, you'll have remembered that you would have to do the compound angle method, which gives us a, let's see, 2, let's see, it is 2 cos theta. Oops. Yeah, basically I can write without my pad, and my pen just gave up, so bear with my poor mouse writing. So 2 cos theta take 1 shall be equal to, this is 2 cos squared, by the way, to cosine 2 theta. So if that, we can rearrange such that cosine squared is equal to half plus half cosine of 2 theta. Okay, so with that, we can now substitute this cosine squared into this equation to give us a 4, which I factorize out of the integral of 1 plus cos 2 theta. Remember the d theta. Okay, so we have this expression that we can actually integrate. Make sure you have the limits proper, then we can now do the calculation. So we have 4, then we have integral is of 1 is theta, add half lots of sine 2 theta, and put in the limits. So for the ones who have done enough integration, we would know that the sine expression would cancel out if you have an integer multiple of pi. So that means that this term will go away in this case, and we're left with the theta. And now we can simply write 4 times pi as our solution for the area, because it's pi takes 0 or times 4, which the 0 cancels to just 4 pi. That would be the enclosed area. And in this case, we can actually do a logic check for this solution. So we have a radius of 2 to 4, which is a radius of 2. And the radius of 2, according to the circle area pi r squared, is pi times 2 squared, give us 4 pi. There we go. So we have shown that both solution agrees, and we have a solution. That's pretty much it for integration polar area. There are more. Just do example questions as practice. Make sure you remember the half r squared d theta equation, and you should be fine with any questions. It is important to check your domain during your calculations, but other than that, it's all simple integrations. So as long as you know from which angle you're starting and which angle you're stopping, you should be fine finding the area. For example, in the example section, I did the 4 cosine theta example. Many people would do a 2 pi to 0, thinking that that would include all the lines. However, that would mean that you have a repetition of a negative line, so you essentially trace out the circle twice and you'll get twice the area. Yeah, basically that's it. Let's do some example questions. The questions are as shown here. We have question 1, which is a simple one, and question 2, it's enclosed by 2 different lines. So yeah, you have 5 seconds to pause the video and take a look at how to do these, and I will show you the answer in 5, 4, 3, 2, 1. And the solutions are shown right here. So first one is 9 on 8 pi, second one is 16 on 3 pi cubed. Make sure you leave your answers in exact form, because decimal might be penalized. And so that wraps up the video, and this is also the last video of chapter 7. Thank you very much for watching, and if you have any questions to do with anything polar, let me know in the comment section below, and I will see you on my next one.